All right, good morning or good afternoon, wherever you're joining us from. Welcome to Prolon Controls version 7.5.0 Focus software release. Just a couple housekeeping things before we get going here. All mics are muted and we're going to keep it that way. If you have any questions to ask, please do that by way of the chat panel. I'm sure we're going to still have some people trickling in here. We've got Sophie managing any technical issues. You can reach out to Sophie Delicio if you're having any problems. So I can continue on with the presentation. Just to note with this presentation, it is going to be focused strictly on 7.5 of Focus. So this will be approached as if you were already familiar with Prolon up through 7.4. I will reference some older features as they are relevant to the changes that have been made in 7.5. But if you need training or education on how to get this going from the ground up, we will have that discussion at a later time through your distributor. So at this time, we'll go ahead and get started. My name is Chris Lyon. I'm a technical sales representative with Prolon Controls. So I do everything from sales calls with contractors to potential customers, all the way up through giving you guys your full technical training to get you equipped to sell, install, and service Prolon. So starting off with our 7.5 release, if you're not sure where to get your new software, you're just going to head over to proloncontrols.com. That's our website. Right up here at the very top, this is where it always is. This is always the most current software. If you click on that download Focus v.7.5, that will take you to the page where you can choose if you need software for PC or Mac, and then you can get that downloaded. So let's go ahead and jump straight into it. And first off, we have adaptations to the chiller and boiler controllers. We can now receive supply water temperature over the network to these, which allows one sensor to be shared by an entire water system. We've had barriers before where we needed a chiller controller, we needed a boiler controller, we needed a Flex IO, maybe a fan coil controller, and we had to put in independent water temperature sensors for every single one of these because we couldn't share this information between the controllers. What this is going to look like is, say I have my, here's my boiler and chiller, addresses 20 and 21, and say my boiler actually has the physical temperature sensor installed. We are working offline with controllers just to be a little more expedient in the presentation here. But if I have a physical sensor installed on this boiler, what I can do is I can take a step back to my network controller, go up to my top level here, and I will be able to find distribution and look at this. We have supply water temperature, okay? So supply water distribution, just like your outside air temperature, I need to go and tell what controller has the physical sensor. So I'm going to browse, I'm going to find my boiler. There we go. So there's my source that has the physical sensor, and now I can choose where I need to distribute this to. So I can send this over to the chiller, and that chiller will now actually be able to control. All of its sequences are going to be based on what it is receiving from the network about that chiller. Now, of course, there will be a little bit of a delay in that, but typically these are going to be larger systems that have somewhat of a buffer capacity to them, and the change is going to be a lot slower. But you can adjust in your communication how often the data is distributed. So right now it's set for 30 seconds. That's factory default. And we'll come back. I know you see this new box over here. We're going to come back to that later. But this is your delay. So every 30 seconds, you'll be getting updated. Typically, that's going to be enough update for a normal system. So let's go back here and continue on. The network controller. This is a big one here, can now save and apply templates. So why can I save and apply templates on a network controller when I'm only allowed one network controller in a project? Okay, and the whole purpose of this, and you can see it simply right here, template. I can load a template, and you're going to be able to load it from my projects. Okay, if you've been to the trainings, you've heard me talk about snapshots and the importance of taking your snapshots, especially before final delivery, before you turn stuff over to the end user. Get that snapshot to prove it as a restore point. You know, after you've proven everything, you've commissioned it, you know it's working. That way you have a restore point if you need to reset things. So you have that snapshot. Say you have a network controller fail for some reason. There was a power event, somebody hooked something up wrong, and it was extremely detrimental, and it destroyed the controller. It's been programmed, you just lost all of that programming. Well, now you can apply a template, and typically we're going to expect from a snapshot in order to restore that network controller without having to rebuild everything manually in there. So at this point, now every single controller in Prolon is capable of saving and applying templates. So no more limitations on anything. Every controller can do that. Continuing on. This is exciting. I'm just going to leave this as a little teaser right now. We'll talk about this later on. We have the TreeComm added. We're adding support for the TreeComm communication. I'll talk about what that is later. But 7.5, the hex files for the controllers, adds all of the communication support to be able to make use of the TreeComm. And we'll talk about what that is at the end of the presentation here. We're not going to get too much into the details. Moving on to the Flex IO. We've got some nice new features here with we can control outputs based on the results of other outputs. I don't know if you can see, I'm hoping you can see my cursor here, but we have had some situations where the logic that we were doing, we had to take an output and we processed one logic on that output, and we would actually bring it around on a physical wire and stick it in on an input on the other side of the controller so that we could then continue that logic through the next step. Okay, so I'll show you how this works in just a sec here, and then we can now have a differential band of 0 when our output source is a math function or another output. So we've always required some form of a dead band in there. Typically it was 8%. We required a differential spread. We can now have 0 on that. So let's go look at that and where this is going to come in. I have a controller. This is the old version of it. Now this is actually a real project. This is a template off of a real project that we did in San Antonio, Texas, where we have a 2-pipe system that does automatic changeover between boiler and chiller based on outside air temperature. And this was one of those situations where I needed to establish one logic that would then cascade into another. And we made use of analog output 1, and we had this send a signal on a physical wire around to input 1, which we called cool mode active, and then we were able to cascade the logic in through there. But that cost us an input and an output. In order to do that, in addition to, I don't know about you, but I feel it does look a little odd having a wire come out of a controller and go right back into the other side of the same controller. So we're able to do that a little bit cleaner now using the new feature where I can have this cool mode enable is now a virtual output. Okay, we've had the VOs. The VOs are nothing new. But now this virtual mode output, I can set this up as, let's go get our digital input for hot to cool change. And we're going to look at, nope, that's not the one I wanted. We wanted the chiller enable. Okay. So if we're going to deactivate this when my cool mode enable is off, I don't need my chiller running. Okay. So I was able to bind to that output there. On my driving the valves, okay, when we're moving the valves from cooling to heating or from heating to cooling, we have to keep temperatures in mind. If I'm going from hot to cold, we do not want to have hot water getting sent, and I built this earlier and it is messed up, but we can go, let me just show you here. We're going to have local output, and we're going to base this on cool mode enable. Okay, and if that is on, we can have a set point for on, a set point for off. So what we did previously with the old sequence is when we turn cool mode on, we're shutting down the boilers, it's getting warm outside. We have to make sure that loop cools because we can't pitch 140-degree water over to a chiller. Okay, so this is going to allow us on the heat to cool change to make sure that that loop cools before we shift the valves. Now, there's some very specific requirements related to the sequence. This is just one of many things that you can do, but I can grab this output as a reset source. I can grab it as a source for direct control. Okay, so any of my outputs can then cascade into another level of control in there. Let's move on to the next controller. I'm going to come back to that math function being 0. And we'll talk about that in just a sec, but we're moving into the RTU controllers. And this is where we have had some significant changes. Up until this point, we've only been able to support up to 4 stages of cooling. We can now push all the way to 8 stages. When we have had that 4 stages, you're familiar with the Demux 4J expansion board that we had to use, where we had a PWM signal from DO2 that would talk to the Demux. The Demux would interpret that PWM signal as, do you need 1, 2, 3, or 4 stages of cooling? The Demux now becomes optional, and we actually have the ability to recover DO2 and DO3 as digital outputs, and we can use those for your Y1 and Y2 calls for first and second stage cooling. And rather than have it sitting there blinking away, being a waste, and not being able to make use of those outputs that you paid for. We have a configurable fan startup delay. Okay, and this is based off of PowerUp. The intent here is if you have, say, a power loss to the building, so you got 20 package units, it's been hot out, everybody's got a demand, power comes back on, and you have all of your delay timers for your compressors. We turn the fans on at the same time, so you have a hit with the surge of inrush current on the motors. Then everybody's compressor timer times out at exactly the same time, and all of your compressors slam on together, and you have a massive surge from all the inrush current combined of all those compressors. So your configurable fan startup delay is going to stage those fans in sequence, and we don't start counting for the compressor timer until that fan is proven. Okay, so this is your delay to avoid those massive surcharges for demand caused by multiple simultaneous inrush current of multiple motors turning on at the same time. Okay. We do have now a pre-purge and post-purge fan delay. Post-purge, think of that as like your residual cool, your residual heat, getting that out of the unit, pushing it into the space if you're running in a intermittent fan control. Pre-purge, we're just gonna get air moving through the unit, kind of get the unit to the same space temperature before we start firing up heating or cooling in that. We have an alternating priority sequence when you're dealing with a VAV or VVT zoning, or sorry, just specifically a VVT zoning system, where we have to change over between heating and cooling. Okay, in the past, we've been able to set a priority either manually heating, manually cooling, or we could have it change based on outside air temperature. But it would still focus on whatever the priority was. If that priority, you say your cooling priority and your cooling demand never went away, we're going to be stuck in that. We will never deal with a heating demand. We now have a timer function in there where we can have that time out, and we will actually force a change over. So that's been something that has been requested. Okay. Here's something that's been on the request books for a long time. We can now go all the way up to dual enthalpy economizer. And I'll show you how that works. There are options now for using AO3 directly as analog cooling. So you're going to give up your duct pressure control, which we can manage that through a flex if we still need to for whatever reason. But I can do analog heating and analog cooling in a single M2000 RTU or RTUS. Okay, we used to be limited there. We had to have the PTA2, which is another expansion module like that DMUX that we were talking about previously. We used the PWM signal on DO2 going to the PTA2, and that would give us our 0 to 10 or 2 to 10 volt signal to drive our valve or whatever we had going on. We can now drive that direct from AO3. Okay. Input 4 now has a new option for alarm. Okay, so that alarm, we're basically thinking the means of like tying into auxiliary contacts on a duct smoke or something to that effect. We have had requests for this. Now, depending on your codes locally, you're going to need to pay attention. Many times they're going to require that you actually cut control power. So this may not come into play. This might be a secondary, an auxiliary way to shut things down for some other means. Another huge sequence that we have added, Vernier compressor control. Okay, you are going to give up analog heat on this, so like a modulating heat source. Again, we could handle that through a FlexIO if we did need to add that back in. But if you're not familiar, I know here in the US, we don't use the word Vernier too terribly much. Our Canadian friends are going to be more familiar with that. But this is designed specifically around your units that have that Copeland digital scroll. And it's designed specifically around this particular unit, the 0024-01 that was designed for air conditioning. It has the 15-second duty cycle, basically operates that digital scroll cycle with a pulse width modulation type control off of a 1 to 5 volt signal. So we can modulate that compressor and then we can control 1, 2, or 3 fixed stages beyond that. And we use that vernier stage, that modulating compressor, as basically a trim stage so that we can target our specific discharge air temperature that we want for typically a VAV system. Okay, we did make one change here with the RTU in the economizer. You know, typically you're going to control off of discharge air on that. We do require now that the damper opens 100% before allowing mechanical cooling to kick in. Okay, so I know I've thrown a whole bunch of stuff at you. Let's go take a look at setting some of this stuff up in Focus. So we'll head back over here to Focus. Here is my rooftop unit. Okay, we're just going to open this guy up. And if I head to my fan, remember we've got 2 pathways. I can either go double click on my fan, or we can go to config, and fan gets me to exactly the same place. I have my pre-purge, I have my post-purge, I have my start delay. So if I'm running an automatic fan control here, once I reach the point that my fan needs to shut down, which usually that is coordinated with a cooling or heating set point, we're going to make sure that that fan runs for at least 2 minutes beyond to get our residual cool, our residual heating be out there. So by default, 15 seconds is a start delay on the fan. This is one of the few things that you will need to go into every single controller on your project and randomize this number. Okay, this is the one thing that you're not going to want in sync. You're probably going to want to offset these by at least 5 seconds each. And that's to make sure that you don't have that simultaneous inrush current from multiple motor startups. Okay, so there's your start delays. Setting up our cooling. Okay, check out how long this list gets now. Remember what this drop down used to look like? Look at that, 8 stages. Analog, and then here's where we get down into that vernier, vernier +1, vernier +2, vernier +3. Okay, a vernier stage is the variable stage. Okay, when we're talking about the +1, I'd have 1 digital scroll, 1 fixed capacity compressor. Okay, vernier +2, 1 digital scroll, 2 fixed capacity compressors. Okay, so we don't really see these units that have more than a total of 4 compressors in them, with 1 being modulating. So how would I set this up? I've got 2 stages. We can go 3 stages. See, now we have this checkbox. We're still going to support you if you're using that demux. Okay, so we can go 3 or 4 stages with that demux module. So don't worry, we're not taking anything away. If you are interacting with an old controller, say a 7.4 or before controller using your 7.5 software, and you have 4 stages, you will see this box will show up and it will be checked, but everything's going to be grayed out. You will not be able to uncheck that box. You will need to update the firmware in the controller, replacing that hex file with 7.5. Then you will be able to uncheck this box if you wanted to rework that. Okay, but once we continue beyond 4 stages, as soon as we hit 5 stages, Flex IO is required. Okay, we're not using the demux anymore, excuse me, for anything on that. So if we just set this up, let's say we have 6 stages of cooling. Okay, you're going to see your set point, your differentials. We did not bother with trying to set all of the set points and differentials in this. We would be happy to help you with our tech support team. If you wanted to call in, we can help you choose numbers that would work. But just creating all of the variables for this with the way the program is written was difficult, so it was easiest just to leave it with the default values that we've given you previously for 1 through 4 stages. And when you're stepping beyond, you know, maybe this one's going to be our 90. Stage 5, we'll say 65. Stage 4, we'll do 50. Stage 3 might be 35, 20, and 10 in there. A little quicker with our drop these down. We're going to have a little bit tighter movement on this. Okay, so I've got my 6 stages. I'm ready for 6 stages. But how do I get 6 stages? If we go and look at our documentation. So I'm taking you to our website, and the reason I'm doing this, I want you to see we have all the documentation ready to go. You can look this up yourself. Not that we don't like talking to you, but we want you to be able to be independent on this. So I'm going to head over to my rooftop controller here. When I get down to my documentation, I'm going to choose the hardware guide. Okay, hardware guide M2000. We can scroll down and we get the detail on the I/O here on page 9. We start looking, okay, DO2, Y1, DO3, Y2. How am I getting 6 stages of cooling out of this? I don't have any way to be able to manage that. Well, if you remember, we had Flex I/O required. Feature that we added in 7.3 or 7.4. I think we added it in 7.3 and kind of revised it in 7.4. Was in the math functions. Remember, this is a master, this rooftop here, large square icon, it is a master. It is in charge of this zoning system. So I can go under my math functions, and maybe we have our weighted average cooling only up here, driving our cooling. I always like to grab Math 5 just because it's kind of down at the bottom, out of the way, doesn't really get used that much. But if you choose this cooling output, you've been able to do this in 7.4, but you choose cooling output, right here above your cooling coils, you're going to get a percentage. That percentage is going to be based on the current number of stages that are active. Okay, so if I have 2 stages, let's just do the math on this here. So if I've got 100% capacity of the unit divided by my 6 stages, so each stage is going to be about 16.6%. Okay, we're just going to round the numbers down because we did not add the after the decimal for set points in any of that. So one stage is going to reflect approximately 16% on this. We'll just round down on all that. So if I am not, I can't use my demux. I've got the Flex I/O required. So DO2 and DO3 right here, those are going to be Y1 and Y2. I can easily make use of those. But now because I have chosen on math my cooling output for Math 5, that number can get shipped out over the network on the follower bus to a Flex I/O. We'll use M2000 hardware here. Okay, so this Flex I/O is a follower under this rooftop. We'll open this guy up, and now I can set up say digital output 1 to follow a network variable of math 5. We're going to call this guy Y3. Okay, so obviously this is going to be a cooling logic. Now remember what I said, when you have a math function as your control source, we can allow this differential to be 0. So if we go back, this is going to be Y3. I have my Y1, Y2, Y3. So at 48%, I want this to come on. So we put 48 here. Now we have the option to deactivate this output when fan status is off, but we don't need to, because math 5, again, referencing cooling output, is going to be subject to all of the safeties, limitations, everything enforced: minimum on and off, interstage activation, deactivation, fan proving, any of the limits that you find in here that would affect your cooling, stop outside air temperature, or stop cooling when lower than outside air temperature, if your supply air temperature, all of those limits, all of those safeties, everything is still completely intact. The number that is represented above your cooling coils will be directly related to what is immediately being requested and allowed. Okay? So until I determine that it is safe and proper to turn on third stage cooling, this number will not change to 48. Okay? Now, technically, I could use any number between 32 and 48, and it would still work on this. Okay? But this just allows us to set that up real easy. I don't need a differential in there. Now we can continue on. I'm going to set up network variable following math 5 again. So we had Y3. We're going to get our Y4, and we just continue on down. Now, if I decided for whatever reason, so we're going to take we had our 48, we're going to add another 16 to that, so 64. So that's where we're going to want this guy to come on. Again, cooling action. I don't need to make any bindings, no other safeties or anything, unless I wanted to step in here and say, well, you know, if outside temperature is less than, 85, I definitely don't need to be stepping up to 4th stage. Okay, so we could set that to off. So you do have the options, but it is really not necessary in there. So you continue setting everything up. Now those numbers, all of those numbers will be available starting at 0. If I decided for wiring purposes that it was not convenient to have Y1 and Y2 coming off of one controller, and then Y3 through Y6 coming off of a separate controller, and I wanted all of them on one physical controller, you could do that. You could ignore DO1, ignore DO2, and you could set up starting at Y1, Y2, Y3, so on, with the FlexIO and have everything physically wired to that controller. Okay. Now continuing on with the Vernier sequence. This gets really nice having this available. Let's just go ahead and I can do a Vernier +1 stage with a single M2000 RTU or RTUS controller. Okay. I don't need to expand beyond 2 digital outputs and 1 analog output. Now, if you pay attention to the controller that this was designed for. Again, back to that Copeland Digital Scroll controller. There is a set of contacts in there. Let's take a look at this real quick. If we look at the wiring diagram, here we are. You'll see that there is a contactor, your M1 and M2. Okay, so technically, this controller could operate the compressor from start up through its whole modulation back down to stop and shutting the motor off of that 1 to 5 volt signal that is being provided. But what we see happening with manufacturers is that they are putting a second enable relay. It still wants a Y1 command to allow the motor to start, in addition to the 1 to 5 volt signal to modulate the compressor. So that being said, we have DO2 providing your Y1 signal to start that motor if you need. You do not have to make use of it, but most of the time you will be based on the manufacturer's requirements of what they need for signals, okay? We do note it is built specifically around Copeland Digital Scroll Compressor. Okay, they really have a corner on this market. There's nothing else out there operating in this manner until you just get straight into a VFD compressor. One of the problems with the digital scroll is that it is allowed to operate at such a low capacity, we cannot get adequate oil return to the compressor. Okay, per Copeland, you can run this down to 10%, but at 10% capacity, you end up vaporizing the oil, atomizing it out of the compressor. It gets caught in the evaporator, doesn't make it out of the condenser, whatever, because we're running at such low pressures, we don't have the velocity to push that oil back to the compressor, okay? Some sequences, they just raise that floor. Other sequences, they actually have a flush cycle in there where they'll crank it up to full capacity and push that oil back into the compressor. What we have is we have an adjustable floor. That is this activation level here, okay? So your activation level is basically the percent capacity of the compressor, 15%. We will never go below that. Even when I calculate that I want that compressor running at 10%, I'm still going to actually operate at 15% to make sure I get that oil return. And you can adjust this to whatever level you determine you need to get the oil return for your particular installation. Okay, so if I decided I needed to adjust this up to 20%, that's great. I can modulate that compressor from 20 to 100%. It will not ever at any time go below 20% other than to stop. So the way this works, I'm producing my demand. I'm calculating based on the heat load in the building. It's increasing. I'm at 10%. I'm at 15%. Okay, I hit 20%. I start the motor. My 1 to 5 volt signal is going to snap to the 20% command. Okay, it will instantly snap to that 20% command. Now we're going to start modulating that compressor. We're going to increase that capacity up until we reach 100%. Now that digital scroll, it's not dropping that fixed scroll out at all. It's pumping 100% of the time. Once I calculate that I need 120% of that compressor, I will then bring on my first fixed stage. Once that fixed stage is on, I will immediately snap that 1 to 5 volt signal back down to the 20%. And now we're running at 120% capacity of one compressor. And now we will continue modulating that up. In order to cycle down, that's where we're going to focus on this deactivation. Okay, so I'm going to need to get down to a point where I would really like to operate my digital scroll at 5% capacity. Obviously, we can't do that. I'm still going to be operating it at this 20% capacity. But based on my function and the system that I've got operating now, I want to operate this compressor at 5%. Once I hit that mark, I will deactivate my highest fixed stage, if I have one, at which point this signal, this 1 to 5 volt signal for the variable on the compressor will immediately snap back up to 100%. And we're going to start working our way down again. Okay, I will run at that 20% capacity all the way down to the point that my digital scroll is the last compressor running, and I now calculate I'd really like to get it down to 5%. I'd like to modulate at 5%. I'm still moving at 20%. That's the point that I turn the motor off. Okay, we set that up the same way if I'm using Vernier +2, Vernier +3. Now you see your Flex IO required. Okay, and we're going to do just exactly what we set up before with our Y3, our Y4. So DO2 is going to be that enable for the Y1 digital scroll compressor. DO3 is going to be your Y2, your first fixed stage. Now, when I want my second fixed stage in here, we're going to ship that out using our math and the cooling output. And that cooling output is going to be directly related to when we're in the Vernier control, it's going to be directly related to the compressor stages. It is not going to be floating with the total capacity. So I understand that this is maybe a little hard to get your head wrapped around if you have not seen or worked with these compressors. If you do come across this, again, I'm going to put a plug in here for our technical support. We are more than happy to sit down and do a little training session, little assistance on getting you to where you're going to be successful in setting this up correctly. Okay, but we're going to base this off the cooling output. And now, say if I have my Vernier +3, okay, it's going to be real easy. 25, 50, 75, 100. I've got 4 compressors. Okay, so we'll set up Y3 is going to be coming on at 75, and Y4 is going to come on at 100. Okay, nice, easy math. We didn't have to mess with the differentials. We had to set things low. We had to account for a differential band in there and make sure that we crossed a line far enough to get things to trip. Okay, not the case anymore. So I realize I'm throwing a lot of stuff at you here. We're going to set this on the back burner here because I think we've spent enough time on that. Moving on to the economizer. Okay, check this out. Now we have mode dry bulb. This is what we've always been. We have always been dry bulb. Now, if you choose single enthalpy, this is probably what's going to get used the most when people do enthalpy. We still have your control curves that you're used to. Okay, A, B, C, D. We even threw in E. So it's going to tell you what your curve is based on. You know, a lot of times we just kind of crank it to D and go with it, make sure that it's good air. Now, rather than accepting a single enthalpy signal that is representing your BTUs per pound of air, we actually will still take the dry bulb signal that we've had, and we are going to now have the option here on input 5 for an outside humidity on a 0 to 5 volt. Okay, we can also get an enthalpy contact. I'll touch on that in just a second. So inputs 5 and 6 here have been lonely for quite some time. Ever since we came out with the T200, T500, T1000 communicating wall modules, inputs 5 and 6 were the old school method of sending a 10K type 3 temperature for the space and a 10K potentiometer for your set point. When we stopped using those, these guys, they really needed to find a new purpose in life. Well, we found that for them. So your outside humidity will go in here. We're going to then calculate the enthalpy based on your dry bulb and the humidity. That's going to leave the door standing open. I'm sure in the not too distant future, we will be adding dew point as a control method. We'll be able to calculate that as well, because there's many regions in, especially in the Midwest, where they use dew point as their control, okay? Now, if we are using a supply temp or a mixed temp, this is the slight change. If you remember in the past, let's go back to our damper position. You're more familiar with these two set points where you got your alternative set point and differential for stage 1 when your economizer was enabled based on outside air temperature, okay? So if we're controlling off of supply temp or mixed temp, there is no reason for us to be allowing mechanical cooling until we have that damper standing wide open, okay? So we can still lock out and say, no, I've been aggressive enough with my damper settings that if economizer is enabled, I should not need mechanical cooling. And once that economizer damper is doing its thing, you will not be able to turn on a compressor, okay? But if you do permit mechanical cooling, we will have to reach 100% open on that economizer damper command before we allow the compressor to come on. And then we're going to also stop mechanical cooling if the economizer goes below and this is not reduces 15, if it goes below 15%, because we could easily see, you know, say we're targeting a 55-degree supply air temperature, economizer is enabled, and it's say 60 degrees outside. We get that damper wide open, bring on a compressor. Well, now we're going to get below our target supply temp, so we'll start closing the damper down. So at this point, it's almost like our economizer has become that vernier stage, that trim stage that we've been talking about with the compressors and the digital scrolls, okay? So we can do differential enthalpy, and again, this is going to come back to our inputs. I've got my outside humidity. We've already been able to take a return or indoor humidity sensor in there, and we will calculate our indoor enthalpy by way of space temp compared to the return humidity, and you can apply your differential enthalpy to that. We can also just take an external contact. You can have an economizer module or whatever, making your determination that the enthalpy is satisfactory or not, and just basically enabling or disabling the economizer function with a simple on-off feature. Okay, so back over here with our PowerPoint. Again, we have the fan startup delay on the RTUS as well. That's what we're pointing out here. Still have the same pre-cool and post-purge fan delays with those as well. So, announcement, the TreeCom. What is the TreeCom? You may have heard this, you may have seen it teased a little bit. Prolon, up until this point, has been absolutely 100% hardwired. It has come to present some situations where Prolon could not be installed just because of whatever the circumstances, we could not get wire through a certain area. We now have a wireless solution, okay? This is a wire replacement for situations that have difficult or no access. The example I like to give is we're coming down the hallway We've got the drop ceiling, pulling our daisy chain, hitting all the controllers, and I reach the lobby. And the lobby is hard lid. I can't get across the lobby, but I have to get across the lobby. And we can place one of these modules on one side, go to the other side of the lobby, place another module, come out of it, go back into our daisy chain and continue with the wired system. Okay. Being that we call it the tree comm, we use a nomenclature of root and leaf. So we're going to be using this in conjunction with wired systems up to 127 address combinations. And these addresses exist outside the Modbus address that you're already using. This is a completely separate addressing. It's not going to occupy an address in focus. It is totally isolated. You will actually not even see these modules in focus, at least not as of right now. Okay. Easily supports one-to-one and one-to-many connections. So say I have a network controller and I've got 5 rooftop units out in a warehouse. And with all the shelving out there, I really can't get a lift through to pull wire, but I can get a basket here and I can go up. And I can get another basket over here and I can go up. Okay. We can have one tree comm at the NC2000 talk to all of those rooftop units, each one having their own tree comm, and they're all on the same channel. Okay. Not going to get into the details on this right now. We will have a separate webinar when we actually release this. I will put a plug out there. We are looking for beta sites right now. If you have some place that you would like to try this out, Prolon is willing to give free of charge as many as 12 of these devices for you to test on a project. Now, of course, that comes with the understanding that they're maybe not 100%. We think we've done a really good job so far. We've done a lot of testing ourselves, but we want to get some real world feedback. So we will be looking for feedback. And there is also the understanding that you may need to go back and do some sort of a firmware update to this device, which we will equip you with to make final tweaks or something to get it working 100%. So we're looking for beta sites. If you have something in mind, reach out to your distributor and ask them to get in touch with us, and we'll get that all set up. Okay. And the other thing to note is this can be used between any points. Okay. Let me show you what I'm talking about. Okay. I can have, say, a wall module that I can't get wire to. So because the wall modules are communicating, it's still RS-485 Modbus RTU communication. I can put this in on that segment. I can have one root talking to multiple leaf nodes in here. At any point, I can choose to add daisy chain wiring. Just because I pulled out a wireless module doesn't mean now I'm stuck committed to using wireless through the whole thing. You can use the wireless only in the compartmentalized areas that you need it. Now, and I really want to caution against somebody who's got the wheels turning in the back of their mind thinking they're going to put in the wireless Prolon system. Okay. We've built a very robust device. It's extremely reliable, but we have all seen wireless systems out there, I won't mention any names, that they're not 100% reliable because of the wireless environments we live in, between Wi-Fi, Bluetooth, cell phones, electromagnetic interference from fluorescent lights, LED drivers, all this kind of stuff. We're living in very dirty environments. It can get in the way of the wireless signal. Now, this is in the 2.4 gigahertz spectrum, so you're going to get good penetration with the low frequencies there. You're going to get long distances. The official from the manufacturer of the technology that we use, this is based on Lumen Radio's Mira technology. The range is up to 1,000 meters. Okay, so you could realistically use these for building hops. So just put that bug out there. We're not sure what we are going to officially state for the range on this, but that is what we get from Lumen Radio about their Mira technology. So I have a question here. Is the root and the leaf the same device? Yes, it is the same device. What designates a root is turning on dip switch 8. Okay, so other than that, everybody gets it's going to be your standard dip switch addressing that I've introduced you to using M2000s, using C1050s. Okay, if you turn on dip switch 1 and 2, 1 plus 2 is 3, that's address 3. One of your tree comms on channel 3 is going to need to have dip switch 8 on. He's going to be the root. Everyone else will be leafs. And they can all talk together. So, and let's see, we also had one other question. Okay, Bob asked, what will happen to the dehumidification function when using dual enthalpy? And the answer there is we can start dehumidifying using the economizer, but you will still have your mechanical dehumidification available if you need to. So, because we will already have that input designated as a humidity sensor, and that sensor, once it's physically into the controller, can go multiple different ways in the logic. So it's not like you have to choose, are you going to use that humidity sensor for dehumidification or for dual enthalpy control. Once it's in, it's available. Okay, so we are right up to our time on this. I want to thank everyone for taking time out of your day. If you have any questions about anything, you can go check stuff out on our website. We have all our reference materials, 877-977-6566. That's our toll-free number. Choose option 2 for technical support if you have any questions on that, and we will help you out with application selection or anything else. So one last question back to the TreeComm. I indicated they will all talk together. Is this in a mesh style network? So technically, if you go to Lumen Radio and you look up their Miracast technology, it is a mesh network. We, at the moment, are not making use of the mesh feature. It is going to be a one-to-one. Each leaf will need to be able to get back to the root on its own. So, but that one root can talk to multiple leaves, is what I was getting at there. So that if I had, say I had 5 zone dampers that needed to talk to the rooftop, I would not need a cluster of 5 root nodes sitting at the rooftop to be able to receive the signal. I would need 1 roof node and it could talk to 5 leaf nodes. That was the point I was trying to make. So again, thank you for your time. Appreciate it very much. Any questions, give us a call, and look forward to seeing you for trainings this fall. Thank you.